Hello, ladies and gents. How are you doing today? Today we're going to talk about functions. If this is your first time learning about functions, I strongly suggest watching the entire video. However, if you already know what a function is, and you need to brush up on a couple of different things, check the timestamps down below, and make sure you are actually watching things that are going to help you learn. So with that being said, we're going to move on. The main four things we're going to talk about in this video is what is a function? How do we represent functions, what domain and range are, and what are examples of functions. Now, the most important thing that you really need to know is when you have a coordinate point, right? That coordinate point is always written as x, comma, y. Okay? Coordinate points are always the x values are first, then the y values. Okay, that's super important to remember this fact. So, I want to tell you a quick story. If you go to a vending machine and you walk up to the vending machine, you put some money in, and you click a button, when you click that one button, doesn't the vending machine spit out some kind of food or drink or something like that? Of course it does. Now, if you walk up to another vending machine and you click one button, meaning you have one little input, right? But for some reason, the vending machine spits out two pieces of candy or two drinks or whatever, wouldn't you say the machine is broken? This is kind of like the idea of a function. What a function really is this whole idea of an input and output system. You can input a number, and it should output one and only one number. Okay? This is not going to really make sense yet if you haven't had experience with functions, but we're going to get there. The real mathematical definition says a function is a set of ordered pairs in which each x element has only one y element associated with it. So for example, I'm going to make another page. If I have, and we talked about what a relation is, if I just have a relation, so let's say 1, 2, if I have 3, 4, and let's say I have 5, 6. Remember, these are my x values are on the left, so 1, 3, and 5, and my y values are on the right, 2, 4, and 6. What a function says is, well, if I input the number 1, it gives me the number 2. If I input the number 3, it outputs the number 4, and if I input the number 5, it outputs the number 6. This whole thing would be considered a function because for every x value, it gives you only one y value. So let me show you what not a function is. So not a function. Let's do it in a different color. So if I were to give you the set of these numbers, let's say -1, 1, 0, 5, let's do 0, 6, let's do 8, 11. Okay? Remember, a function is when you input a value for x, it only gives you one value of y. So if we look at all of the x values, we have -1, we have 0, so -1 gives you 1, 0 gives you 5, but 0 is also giving you 6. So do you notice that in this relation, this set of ordered pairs, that there are two values, or rather two different coordinate points, that both have an x value, but they output two different values? This is what you would consider not a function. Okay? Look at all those marks. So, look at all those marks. So, if you look at all the x values, do any of them repeat? Well, yeah, look at these two guys over here. 0 repeats, and they both give you different values. This would not be considered a function. Now, there's different ways to represent functions. So, for example, we're only looking at like a list or just order pairs. But there's many ways to represent functions. So we have a list. And again, we can check out over here. If you look at each x value, -1 goes to 2, 0 goes to 3, 1 goes to 4, 2 goes to 5. None of the x values repeat. Must be a function. Same thing with a table. A table is the same thing as a list. We did this in class, only it's just written kind of like sideways, and usually we use tables for graphing. So -1 goes to 2, 0 goes to 3, 1 goes to 4, 2 goes to 5. Mapping is, I think, a pretty interesting way to represent a function, because a mapping is a visual representation. So on the left-hand side, I have all my x values, and on my right-hand side, I have all my y values. And a mapping is literally showing you an arrow of which value maps to what. So essentially, if I input, let me do it in a different color. If I input -1, it's telling me that it's going to output the value of 2. And if I input the value of 0, it's going to output the value of 3, and so on and so forth. There are actually different names for x values and y values, but we're going to get there in a second. Okay? So there are two other ways that we're not going to explore in this video. One is called a rule, which is, you've probably seen it as like y equals, but we're going to be using this notation f of x equals. This really means a function where the variable is x. Okay? And also we can represent functions using graphs, which we're not going to focus on for today. So, we know what a function is. We know what functions should look like. They can look like a rule, a graph, a set, a table, or a mapping. But we got to know a couple more vocabulary terms. So, these words, domain and range. We've seen these words before, but this is exactly what it is. A domain of a function, or even a relation, is just all of the x values, or rather, all the inputs. And the range is all of the y values in the function, or just all of the outputs. So remember when we were talking about this machine? When you input something, you can say that that's the domain. And then when you output something, that is called the range. So let's do some examples. Let's say, I'm going to pick my favorite color, which is this one over here. If I give you this set, I want to know, is it a function? And then I want to know what's the domain and range. So a simple way of knowing if something is a function is ask yourself, are there any repeating x values? Because remember, when we saw before, was it here? When we were given a function, if any of the x values repeated, you see how they mapped to different y values? That means it's not a function. So, got to look at all of the x values. Boom, 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 boom. So we have -2, -1, 0, 1, 2, 3, 4. None of them repeat, so is it a function? Yes. Smiley face. Now I want to know what's the domain and range. The domain, and I want to know the range. So the domain, remember, is all of the x values. So what are all the x values in this function? Well, we said it before. It's -2, -1, 0, 1, 2, 3, and 4. And if I said, hey, well, what's the range? And the range is all the y values. So you're literally just going to list all of these y values. So we have 5, we have 0, we have -3, we have -4. We have -3 again, but that's okay because y values are allowed to be repeated. So I'm not going to write that. We already have 0 and we already have 5. So all of the possible values in the range are just 5, 0, -3, and -4. Let's do another example. Okay, which one's a function? This one is given to you as a table of values. So let's check it out. So on the left-hand side, let's see if any of our x values are repeating. So we have -3, 0, 3, 8, -10. None of them repeat, so this must be a function. Okay? Because when you input -3, you get 6. When you input 0, you get 8, and so on and so forth. Since none of the x values repeat, we consider this a function. Let's look at this one. -2, 0, -2. Hold on. There are two values of x that are being repeated, so -2, and they're both being mapped to different values. Meaning, this is kind of like the vending machine situation. It's like if I click the number -2, it's spitting out two different answers, which that can't be if you are looking for a function. So this is not a function. So what is the domain of the range of the function? So of this function, the domain is -3, 0, 3, 8, and -10. Whoops. And if we're looking for the range, well, the range, remember, are all the y values. So that's 6, 8, 20, 4, and 8. Okay, almost there. Let's do another example. Here's a mapping. So recall from before, the left side are all the x values and the right side is all the y values. So I'm going to label it. Here are my x's, here are my y's, here are my x's, here are my y's. So let's look at all the x values. So 10 is being mapped to 2. 3 is being mapped to 3. 5 is being mapped to both 4 and 7. So in other words, again, think of it like a vending machine. If I click the number 10, it's going to give me 2. If I click the number 3, it gives me 3. But if I were to click the number 5, it's giving me two different things, which tells me that this cannot be a function. I want to continue because I want to show you something else. If I click the number 7, it gives me 5. But when I click the number 2, it gives me 5. Is that okay? Of course it can, because the definition says that for each x value, it has one y element. It says nothing about y's having more than one element. Okay, so it's kind of like if you were at a vending machine, you can click like one button and get Coke, and then you can click another button, but you can also get Coke. That's okay. That doesn't mean the machine's broken. But if you were to click a button and you got multiple like sodas or you got multiple like food, which would be awesome, but that would mean it's not a function because it's not a working machine. Okay, let's do this one. So if I click 10, it goes to 2. If I do 3, it goes to 3. If it goes to 4, it goes to 8. If I go to 7, it goes to 4. 5 goes to 8. So notice each x value only goes to one y value. This must be a function. So let's write the domain and range. So the domain of this function, remember, x values are your domain, and your y values are your range. So you're literally just going to list the numbers here. 10, 3, 4, 7, 5 is the domain, and the range are all of the y values. 2, 3, 4, and 8. Let's do some Regents questions. So a function is defined as 0, 1, 2, 3, 5, 8, 7, 2. Isaac is asked to create one more ordered pair for the function. Which ordered pair can he add to the set to keep it as a function? So remember what a function means. In simplistic terms, none of the x values can repeat. So my x values, so the x values, and remember the math term we can use is the domain of this function is 0, 2, 5, and 7. 0, 2, 5, and 7. So if I want to add another coordinate, or rather another ordered pair to this function, none of the x values can be 0, 2, 5, or 7. So can the choice be number 1? No, because it has a 0. How about number 2? No, it has a 5. How about number 3? It has a 7. How about number 4? The x value is a 1. I don't have a 1 yet in this function. So this can be an ordered pair that I can add or put into this function, and we'll keep it as a function. Because if you look at all the x values here, plus this x value, none of them repeat. Let's do one more together. Which table represents a function? So you're going to see this question a lot. The easiest way to see if something is a function, with the stuff we've been looking at, so tables, lists, and mappings, see if the x values repeat. So which table represents a function? Let's do it in red. So for choice 1, do any of the x values repeat? Yeah, these two 2's repeat. So this can't be a function. If we look here, let's see, 0, -1, 0. Oh, these two 0's repeat. can't be a function. How about this one? 3, 5, 7, 9. None of the x values here repeat, but I'm going to just check just to make sure it's this answer. If we look at the last answer choice, 0, 1, negative 1, 0, the zeros repeat. So this cannot be a function. Therefore, answer choice 3 must be your answer. So, to recap, in general, a function is kind of like a machine. You can put stuff into it and it spits stuff out of it. In other words, a function is a set of ordered pairs in which when you put in an x value, it only outputs one y value. So, when we looked at some examples, let me actually go back to this. When we look at this example, for every x value, they're all different, and it only outputs one y value. We also talked about different ways to represent functions. They could look like this, a set. They could look like a table, and they could look like a mapping. All these, actually, if you noticed, all of these are using the same numbers. We're going to talk about later in future videos and future class lessons that a function, one function, can all be represented by all of these different types of ways. So a rule, a graph, a mapping, a table, a set, or a list. Okay, these are all just different ways to see the exact same thing. Okay. The other thing that we learned is what domain and range is. Domain is literally just all the x values, or all the inputs of your function, and the range are just all the y values, or the outputs of your function. I hope this was helpful. This is a lot of information, so this is great to kind of introduce you to these key terms so that when we actually talk about these things in class, you'll have a better understanding. Or if you're just brushing up on some concepts, hopefully this was direct enough so that you got the answers that you were looking for. So have a great rest of your day. Bye-bye.